what is the linear approximation and what are the differentials and how to use them. طبعا by linear approximation here we mean also we use the word linearization. We also after finishing this section you will be able to know what we mean by overestimate and underestimate approximations, what are the differentials and how to calculate the relative and the percentage errors using the differentials. طبعا يا شباب you know that the linear functions are very easy and clear functions. You can sketch the graph of them easily, find the x-intercept, y-intercept, you can do all stuffs related to linear functions. I think you wish that all the functions are linear, so because this will be easier. And I said also this, I say I'm saying this always to my students, that linear always is easier. And unfortunately the life is not linear, it is non-linear. So the linear approximations, they make our life easier because you can represent the complicated functions as linear functions, approximately, of course. So what are the reasons that we need behind the need of making or approximating the functions to be linear functions? Here we have a general function. Let's say this is a function f of x. This is the tangent line to this curve at this point A. What you can notice, ya shabab, that when we are very close from the tangency point, the two graphs are almost the same. So here they are different from each other, but when we are close here, they are almost, the values are the same. So the blue one here is the function, and the red one here is the linearization of the function. This is the tangent line at the point A. You remember the equation of the tangent line? Do you remember it? It is y minus f of a equals to, here it is, just move it to there, this one. So this is the equation of the tangent line at the point A. So now we can use this as an approximation for the function. So we can say that this is equals approximately to the function itself, where when x, of course, so f of x is approximately equals to this. This is linear function. So, but f is not necessarily linear. It could be any function, طبعا. Just we need it to be differentiable. Now, this is called the linear approximation or the tangent line approximation of this function at this number or at this value of x. So let's give it a name to make it easier, shabab. We will give this expression a name. We will call it L of x. So L of x is a function that is called the linearization of the function f at the point A. So this is not always true. It is only true when we are very close from A. This is near A. It is not true when we are here. It will not be accurate. They will be different, not the same. So what we can, to summarize this slide, shabab, we say that the function is almost or approximately equals to its linearization. What is its linearization? Here it is. And this is near A, near x equals A. Let's have an example. Find the linearization of this function. So this function is not linear. What is its linearization? What is the linear function that is corresponding to this function? At, it could be different from a number to a number. So what is it at A, at x equals 1? Let's start with this and we will continue. So let's stop here. Now, how to find the linearization of this function, ya shabab?
Find the tangent line.
So it will be Lx, this is the linearization, equals to f at
A.
If you remember, let me remind you about it. Here it is. It is f at A plus the derivative at A times x minus A. In our case, A is 1. So it will be f at 1 plus f prime at 1 times x minus 1. Here it is. So what is f at 1? Both x equals 1. This should be equals to what? F at 1 is square root of 1 plus 3. It will be square root of 4. It will be 2. So So this is 2 plus this is x minus 1. What is f prime at 1? We need to find f prime in general at the beginning. What is the derivative of x? It is 1 over 2 square root of x plus 3. Is that right? And evaluate it at 1. So it will be 1 plus 3 is 4. Square root of 4 is 4.
1
It will
over
be
4.
4. So it is 1 over 4. This is the linearization. So now we can say that this function is approximately equals to this. What is it? It is 2 plus 1 over 4x minus 1 over 4. It is approximately equals to what? 7 over 4 plus 1 over 4. Yes. So this non-linear function, it is approximately equals to this linear function. Now, this is not always, ya shabab, true. This is just when we are very close, near x equals 1. For values of x, very close from 1. If we are far away from 1, it could be different. Is that clear? So this is the linearization that we did until here. Now we need to use this, yes.
So it's not necessarily at 1, at a, sorry. At the
A,
value.
they are the same. At A, it is the same because it is the tangency point. You know that? At 1, they are the same. Exactly the same. If you put x equals 1 here, if x is a here, what you will have? This is f of x equals to f of a plus f prime at a x minus a. If x is a, this will be what? This will be a. This will be what? 0. So at a, they are the same. It is the tangency point. It is on this graph and on that graph. I'm talking about when we are near a, but at a, they are exactly the same, not approximately. You got it?
Yes, thank you.
So now how to use this fact, ya shabab. Now we have this fact. We have that this is approximately 7 over 4. I think we have it here. Yes, here it is. We have square root of x plus 3 equals to 7 over 4 plus x over 4 when x is near 1, not in general. Now, how to use this to approximate this radical? And you cannot evaluate this radical manually without a calculator, but with the help of this approximation, you can. Who can tell me this is approximately equals to what? 7 over 4 plus what over 4?
0.98.
0.98.
98.
How you know that? Because compare this with this. This is equals to 3. This is 3. 3 plus what? 0.98. So 3.98, it is 3 plus 0.9. So this is square root of x plus 3. So x is 0.98. Now you can do this by hand, ya shabab. No need to use a calculator for this. This will be 98 over 100 times 1 over 4. You can simplify and evaluate it at the end. Here it is, without a calculator. It is 1.995. This is the value of the radical. You can do the same here. Now, in our case here, look here, 0.98, it is near 1. Similarly, the square root of 4 or 0.05, what is it? It is square root of 3 plus what? Why 3? Because this is 3 plus. So this is 3 plus what?
1.05.
1.01.
And this number also is very close from 1. So it is near 1. So this approximation will be very, very good. It will be okay. So now the square root of 4 or 0.5, it will be just 7 over 4, approximately 7 over 4 plus 1.05 over 4, which will be 2.0125. Now, what do you think? Is these approximations are okay, are good, are accurate, or they are not the same? Are they? He asking here, are these approximations overestimate or underestimate? What does that mean? Overestimate, it means that they are bigger or larger than the exact value, or they are less than the exact value. So how can I know I don't know what is the exact value. So how can I know if they are overestimate or underestimate? The idea is easy. Sketch the graph of these functions. One way to do that is to sketch the graph of these two functions. You know how to sketch the graph of this one. Here it is. Oh no, this is the square root. It will start from here. Am I right? It will be shifted to the left. Now sketch the graph of this line. And if you did that, they have the tangency point is 1. So what do you think? Is it going to be above or below? For sure, it will be above the x-axis. So now these values, ya shabab, we calculate them, these values that we obtained them from the line. Am I right?
Yes.
So they are here. So they are greater than the exact values. The exact values are here. So this means that these values that these approximations that we have, they are overestimates. They are more than the exact value. Yes, he mentioned this. So here, so when you have 0.05, it will be here, some point here. This is point there. So they will be above the graph. So the approximations are overestimates because the tangent line is above the curve. If it was below, they will be underestimates. طبعا, if you use the calculator, by the way, look how it will be accurate. Now, this is the radicals, for example, some radicals that we need to calculate. طبعا, this is x, this is the linearization, this is the actual value of the function. By using a calculator, you can find it. Now, look, this is the value that we calculate. We use this one and this one. طبعا, these are very close from 1. And look at our approximations. 1.995. This one, it is 1.9949. So they are accurate until 3 digits. Look, the first 3 digits are the same. Now for this one, if you look, it is 2.012. Also the first 4 digits are the same. So it is accurate here for 3 decimal or 4 decimals. But when you go away from 1, like 3, so look at 3. When you approximate it as a 3, it is 2.5 if you use the linearization. But without the linearization, it is 2.449. So it is just accurate for 1 decimal, 1 digit only. So this is why, Shabab, we are focusing on the point that we are approximating at. So someone will say, why we will do that? We can just use a calculator and it will give me the exact value. It depends on your calculator. It is accurate how many digits it will show you. So this is one way, but of course there are applications that maybe the calculator will not help you in that directly. It will give you the value, but you need sometimes to study the approximations over an interval, not at specific value. Like this example, for example, for what values of x this linear approximation is accurate within 0.5. So here I want the exact to be like the exact value plus or minus 0.5. Also, what is the accuracy to within 0.1? So here we want it to be the difference between the exact value, between the actual value and the approximated value. We want it to be less than 0.1 or more or less 0.1. What is the idea? So I need this, the difference between the approximation. This is the approximation and this is the exact. So I want the difference between them to be less than 0.5. I don't want it to be greater than or even equal. I want it to be strictly smaller than. So now you remember when you have absolute value of x minus a less than k. So this will be x minus a less than k greater than negative k. Now you will just add a for both sides to solve it for x. Now what we will do the same here. So what does that mean without absolute value? It means that x plus 3 minus this is less than 0.5 greater than negative 0.5. Now let's add or subtract this from the 3 sides. So what we will have? Negative 7 over 4 plus x over 4 less than what? less than 0.5 minus square root of x plus 3. Here it will be greater than negative x plus 3 negative 0.5. Now we need to multiply by this negative. So what it will be? 7 over 4 plus x over 4. This will be greater than, and this will be less than. But I will do it in another way. I will make this one here. I will bring it here. This one, it is less than. I will make it greater than, and I will write this after multiplying by negative 1. So it will be what? Square root of x plus 3 minus 0.5. And this one, it is greater than. I will make it less than this. But after multiplying by negative 1. So it will be square root of x plus 3 plus 0.45. I just did 2 steps in 1 step, ya shabab. What is this tell us, ya shabab? It tells us what we are asking about. We want it to be accurate within 0.5. Look, so our approximation, this is the approximated, this is the linearization. The linearization should be less than the exact one plus 0.5 or minus 0.5. So how to do that? You need to solve this inequality, and it is not easy to solve it. Don't try even. With some, if we are going to give you questions like that, it will be easy to be solved. You can solve it. But for this one, it is not easy to be solved algebraically. So what you need to do, you need to solve it graphically. How to solve such questions graphically, this will not be given for you in any quiz or any exam, but it is important for you to have an idea about that. So how to solve this geometrically, graphically, ya shabab? You need to sketch, to use a computer graphing to sketch these 3 graphs. What are the 3 graphs that you will sketch? Here they are. You will sketch this graph, which is easy, طبعا. And also you can sketch this graph by yourself, by the way. It is not difficult. This is just square root of x plus 3 shifted up 0.5, and here shifted down. And this is the linear. You can sketch these 3 graphs by yourself, but you cannot find the intersection points between them without a computer or a graphing calculator. So these are the 3 graphs, ya shabab. This is minus 0.5. This is the without. This is square root of x plus 3 as it is. This is plus 0.5. And this is the red one is the line. Now, we want the line to be between this value and this value. Why it is mentioned here? It should be here. It should be like this. I think it should be like this, between, because we said that we want it between it minus 0.5 and plus 0.5. So the minus is here. So I think it is not true to have it like that. Anyway, so this is our line. Now we want our line to be between these 2 values. Now this is the values, the intersection values. Again, I think it should be there down. Now, if you make a zoom in by using, if you are graphing by using a graphing calculator or a computer, you will see what are these values. You need to find what are the x values here. What is the corresponding? And I think they are what? Here they are, negative 2.66 and here negative or 8.66. So this means that this function is approximately equals to this linearization within 0.5 error when x between these 2 values, when x is within this interval. You can do the same for the next part. In the next part, they ask about within 0.1. It is the same idea for 0.1. So if x is between negative 1.1 and 3.1, you can see here that the interval here is more closer to 1. So because here we want the accuracy to be less than the accuracy in the previous example here. We want here the accuracy to be 0.5 within 0.5. Here it is within 0.1. So the interval we will be close, very close from 1. Again, ya shabab, this is of course not included in the exams, and we will not ask you to use a graphing calculator. If you have a question like this, you will be able to do it manually without any help of calculators. Now, the second part of this section is differentials, and the differentials are approximations for the change of y and the change of x, kind of approximations. So you remember, shabab, that we had f prime of x. This is the Newton notation, and we have in the Leibniz notation delta y delta x. This is a very effective notation in mathematics. We will see also today how to use it. طبعا d, when we say d over dx, we mean here prime. So this means this. You just put f here, f here. You will understand it this way. But if you deal with it like independent variables, like you remember that delta. Do you remember the definition of the derivative? It is the limit when h goes to 0 for f of x plus h minus f of x over h. Now, you know that h is the horizontal change. So let's call it delta x to make it more related to the variable of differentiation. Let's make this a or whatever. Let's make it as it is, no problem. So now, usually we represent this, we call it dy dx. Usually we say that dy dx is equals to the limit of delta x goes to 0 for delta y over delta x. What is delta y? Delta y is this. So delta y is the value of the function at x plus delta x minus f of x. What is delta x? It is the h, the difference between the two values of x. The horizontal change, this is the horizontal change, and this is the vertical change. Now, according to the limits, we can, roughly speaking, we can say that delta y is approximately delta y, and delta x is approximately delta x. Look, if we deal with these two quantities as independent, this one is approximately that one, and that one is approximately this one. Now, what we want to say here, okay, if this is a function that is differentiable, then the differential delta dx is can be considered as independent variable that can be given any real value, any real number. It could be any real number. It is independent. It does not depend on x or whatever. It is h. So if you have here 2, this is 2.1. So h here or delta x here, which is dx approximately, is equals to 0.1. So this is what we mean by that. Now, if this is del dx, what will be dy? dy depends. لاحظوا ان dy هذه طبعا approximately it will be dy. Delta y, it depends on the function itself. So in the case of the derivatives, you remember that f prime is just dy over dx. Now, since this one is independent, it does not depend on this, so we can multiply both sides by it. So you can have like this, dy equals to the derivative of x dx, because this one now is a quantity, is a number. You can multiply both sides by it. So according to that, we have the following definition for the differential dy. So if dx is independent variable, then dy equals to the derivative multiplied by that number. Okay, and as I said, they are approximation for delta y and delta x, approximation for the vertical change and the horizontal change. So dy is dependent, is not independent. It depends on the values of x and dx. And I think should be clear and related to the definition of the slopes of the tangent, if you remember, and the derivatives. So the distance from here to here is delta x, and from there to there, it is delta y from here to here, which is, of course, as mentioned, I think I should add it here. I will add this statement here. It will help you also to understand better. I think we are ready to have an example. Compare the values of delta y and dy. Look, they are not the same. They are approximately the same. So we need to find this, and we need to find this. And this is the function. And we need to compare them when x changes from 2 to 0.5. So what can we conclude from here, Shabab? What is delta x?
0.05.
Yes, the difference from here to here. So it is almost also, it is approximately dx, by the way. So it is what? 0.05. Now delta y will be f of what is a here? So this is a and this is x and this is x plus delta x. So here it is f of x plus delta x minus f of x. In our case, x is 2. And delta x, it is 0.5. 0.5. So this means that you need to find f at 2, 0.5 minus f at 2. This will give you delta y. For dy is easier. Dy is just the derivative at 2, because we say that dy is just f prime x dx. So it will be just f prime at 2 dx. So what we need to do here, Shabab, we need to find the value of the function at 2, because we will use it here. This is f at 2. And we need the problem here that we need f at 2, 0.5, and this need to be this be cubed and squared. So the calculation here will take time. But usually we will not ask you to do that if it is long. Now, delta y will be just the difference between these two. This minus this. And here it is. So you will just subtract 9 from this value. Now look, it takes time to calculate delta y, but if you approximate it by using dy will be f prime of x dx. So just differentiate this function. This is the derivative dx. Now evaluate it at 2, and when x is 2 and when dx is 0.05. So when x is 2 and dx is equals to delta x equals to 0.05, substitute. You need to calculate this, and it is easy. Just will be 4 times 3 plus 4 minus 2, and then multiply by 5 over 100. So this will be 0.7. This one, Shabab, calculating dy is much easier calculating delta y. So we will just calculate this, and approximately will be equal to dy. If you compare this value and this value, approximately the same, of course, and just here it was easier to be calculated. This is part A. Let's see what is part B. Part B calculated with a smaller range from 2 to 0.01. So here we maximize the delta y, the delta x. Delta x here it is 0.01. So you will do the same. This is the value of the function at this one minus the value of the function at this one. Calculate f at 2, then subtract. This will give you delta y. Now, again, it takes time to calculate this part. But if you calculate dy, delta x is given there. So that dy will be very easy. It will be just the derivative at 2 multiplied by dx. And it is 0.4. If you compare also this value with this value, you can see that they are approximately the same. But the good news that this is easier to be calculated. And notice that the approximation delta y approximately dy, and it becomes better as dx becomes smaller. Now here the accuracy is for 2 digits. It was before only for 1 digit. And also notice that dy was easier to compute than delta y. Let's have an example word problem applications for these issues. And they are related to related rates 3.9, but they are much easier. Read the problem, Shabab, for 1 minute, please, with me. Take a paper and pen and try to visualize it. We have here the radius of a sphere. So we have sphere was measured to be found 21 centimeters. So this is R. This is the radius. With a possible error in measurement of at most 0.05 centimeter. What is this? So this means, ya Shabab, that we have a tool here, we have a device to measure the radius of a sphere. But of course, this device is not accurate 100%. So there is a possible error that could be 0.05 centimeter, more or less. It could be plus or minus. So what we can consider this, Shabab? This will be dr. This is change in r, small amount of change of r. The question is, what is the maximum error? Because of course, the error in calculating the radius will affect the calculating of the volume. What is the maximum error in using this value of the radius to compute the volume of the sphere? So what we want, what is required, Shabab? Do we want V or dV?
dv.
We want the amount of error, the amount of change in calculating the error. So we want dV. So this is this of course, if you can translate this from words to mathematics, that's it. You can calculate it. Now, what is the main formula that we need to use here? What is it?
The volume of a sphere.
The volume of the sphere. What is it? Do you remember? Now
4
you should
over 3
by r
cubed.
r cubed. Now, how to find what to do next?
Find the derivative.
Aha, how to find the derivative here, Shabab? You need here to be careful. So what we will say, what we will do? dV, what?
dr.
dr.
Aha, you can think about it this way. You can say dV dr equals to 4 over 3 by times 3r.
squared.
Do we have dr here again or?
No, we differentiating to dr.
Aha, this is okay, Shabab. It is like when you have a function, y equals to a function. When you differentiate, you will say dy dx equals to f prime of x. So in our case here, it is v and this is r. This is r. But why you didn't remember the differentials? We are using here differentials, Shabab. Do you remember that we said if you have y equals to f of x, then dy equals to what? F prime of x d what? dx. So here we will do the same. It is better to think about it this way. It will be dv, the derivative of this, which is 4 by r squared, d what? dr. So it was the same, by the way. You will just need to consider that dr it was here and you multiplied both sides by dr. But you cannot do this with derivatives. We are just doing this with differentials. Be careful, okay? Because here in the differentials, dr and dx are independent variables. They are quantities dependent from the others. Now we have this. We have this. Halas done. We have r, we have dr. We can find dv. And it is solved. This is dv. dv is approximately 277 centimeter cubed. Oh, it looks, the error is huge. So when we make 21 centimeter, this sphere is really huge. The error is 21 centimeter. And of course, the volume will be bigger for sure. Now it is the maximum. How can I make sure that it is the maximum? Because here, Shabab, it is clearly that it is, for example, it is 21 plus 0.05. More or less, so wherever it is positive here, we consider, we don't think about it as a dV here is not positive, a negative. If dV is negative, it will be less than. So this is the maximum error that we could have according to that. Now, don't think that this is big error because it is related. It should be related to the error itself. Let's compute dr. Look at dr. The amount of error in calculating the radius is very small comparing to the radius itself. So to do that or to make that clear, you need to deal with what is called relative error. You need to compute the relative error. So the error related to the quantity, the original quantity. So you need to calculate dr with respect to r. Relative to r. This is dv relative to r. So the relative error will be dv over v, approximately delta v over v. So to calculate the relative error, this is the relative error, Shabab. It is approximately dv over v. Do you have dv? dv, you have it. This is the formula for dv. And you have the formula for v. Now simplify. This will be cancelled. This will be cancelled by with by, this with this. And you end up with 3 dr over r. So this means that the relative error in the volume is about three times the relative error in the radius. So you need just to find the relative error of the radius and treble it, multiply it by 3. So now if you want to calculate dV over V, it will be just 3 times dr over r. dr is what it was, what? 0.05 over r, which is 21. Am I right? Yes, here it is, and this is the r and this is r. So which is approximately equals to 0.00024. So this is the relative error in calculating the radius. Now if you multiply it by 3, it will be 0.07, and this will give you the relative error in calculating the volume. So it is a small amount if you compare it with the huge, or with the original volume. To make it more clear for you, you can make it percentage, ya shabab. How to do that? Multiply by 100%, here or there. So if you did that, you are calculating then the percentage error. The percentage error here, it will be, if you multiply by 100, it will be 0.24%. And if you calculate it in the volume, it will be 0.7%. So the amount of the error, the percentage of the error, it is 0.7. It is less than 1%. So it is very small error indeed. Is that clear, Shabab? I think this is all what we have in this section 3.10. As I told you, to summarize, let me summarize, Shabab, for you now. Let's check our objectives. Are we achieved our objectives or not? So do you know now, Shabab, what is the linearization? What is the linear approximation? Also, if someone asks you the tangent line approximation, these three words expressions are the same concept. Do you know what we mean by overestimate and underestimate? Do you know what we mean by differentials? We have two differentials now, dx and dy, which is f prime of x dx. And how can you use them to find that? You need to know also how to calculate delta y and delta x. Delta y, it is f of x plus delta x minus f of x. And delta x is delta x, it is just x minus. And relative error and percentage errors, how to calculate them. The relative error will be whatever, it will be d whatever, dr over r, dx over x, whatever, dv over v. And the percentage will just multiply this by 100%. I think we have achieved our objectives in this section. Let's go, and if we have time, we have 2 minutes left. Let's go to have a look at the old exam problems. I advise you also, Shabab, to practice the recitation questions, the homework, the suggested homework problems. These are suggested homework problems, and these are the recitation suggested problems. Do we have a solution for this? We don't. Look at this. If Lx is the linearization of this function at a equals 0, then what is L at -1? So what you want to do here, ya shabab, the question is easy. You need to find what? L of x, and then substitute by -1. So it is not difficult at all. And what is this? What is L of x? It is f at 0 plus the derivative at 0 x minus 0. So what is the main part here, ya shabab? Is the derivative. If you are going to do a mistake, you will do it here in calculating the derivative. You need to find the derivative. The derivative of this function is what? The derivative of 2 is 0 plus the derivative of ln 1 minus 4x. What is it? It will be 1
over.
And in the denominator here, we'll write -4, the derivative of the expression. Now evaluate it at, what is f at 0, by the way? F at 0, it is what? 2. When x is 0, this will be ln 1 is 0, plus the derivative at 0 will be what?
-4.
-4. So this will be -4x. Now you need to find, this is Lx. L at -1 will be just 2 times -4 times -1, which will be what? Number 6. Yes, and that's it. I think this is all what we have for today. Similar idea. Look, it is the same idea. This is similar to the example that we solved. Similar to the example. And the remaining questions are solved, and you can compare them and have fun with them, ya shabab. Okay, this is all what we have for 3.10. See you inshallah, ya shabab, next class. If you have any question, I still have like 1 or 2 minutes for you. This is also interesting, but I think it is solved. Yes, it is solved. I don't like solved problems completely, ya shabab. These kind of problems will not help you to understand the material very well. But it's okay. You should try before looking at the solution. You should think. If you didn't think, you will not learn. Any question يا شباب؟ بالتوفيق إن شاء الله يا شباب، نراكم على خير إن شاء الله في الكلاس الجاي.
دكتور
Yes.